And so what we've been working on is called BrainFrame. And what we're aiming to solve here is the problem of video analytics and algorithms and how to put it all together and deploy new products. So here's what we're going to talk about a little bit today. So we're going to start off by, I'll tell you a little bit about video analytics, a little bit about the kinds of problems that get faced in the video analytics space. I'll introduce BrainFrame, which is Autu's solution for deploying video analytics solutions. And then I'll introduce Open Vision Capsules, which is where other people can come in and make their own algorithms for video analytics. And then I'll do a live demo and we'll see how that goes. So starting off, these are the problems right now with video analytics today. So first of all, the video analytics space is pretty incomplete and fragmented. So there's a lot of companies out there that are doing surveillance. They might be doing security. They might be doing train station surveillance. They might be doing airport surveillance or casino surveillance. But there's no product that helps people create a new product for a specific vertical. There's just a lot of separate different products. So if you are a deep learning engineer, you don't know how to get your new algorithm deployed to solve real world problems. And second of all, there's no product out there that can kind of solve a broad underlying segment of these problems, right? So essentially, you know, it's difficult to solve a lot of different video analytics problems all in one go. And so that was one of the reasons BrainFrame came to be. And thirdly, it's very difficult when you're making a new video analytics product to figure out exactly how much it's going to cost. So let me explain kind of what I'm talking about. It'll make a lot more sense once I show the demo. But let's say you're trying to solve a problem in retail. So you might have a data scientist who has algorithms for solving, for detecting people and if they're grabbing items off of shelves. But you're going to need people who have video streaming expertise in order to connect the cameras in the store to your system. Then you're going to need that data scientist to build that algorithm for you. Then you're going to need data management expertise, someone to make APIs, handle the database, handle everything like that. And then finally, you're going to actually need to deploy it. You're going to need to know the hardware you're going to run on, and you're going to need to produce all these things. So BrainFrame is meant to simplify uncertainty with deploying a new product in the video analytics space. So here's how that works. So BrainFrame takes away all of the difficulties of video streaming, of algorithms, and of analytics, and it lets the builder of the solution just pick what algorithms they are going to be deploying with. So if you need to detect people, you add a person detection algorithm. If you need to do face recognition, then you add a face recognition algorithm. But BrainFrame handles the deployment, it handles the data, it handles the video input, and we handle picking the hardware for you. So we're just here to try to make this entire process much simpler. So I talked about modular algorithms. So the way that we do that is we do it through something called Open Vision Capsules. So this is a collaboration with opencv.org. So if you go to the OpenCV GitHub, we've released an Open Vision Capsules format. So for the non-technical, this is a format for the algorithm that allows data scientists who are making state-of-the-art algorithms to write their algorithm in such a way that it can be deployed to BrainFrame and instantly be useful to people who want to solve video analytics problems. So how does this all work? So the first step is you identify a problem. So if you might want to do queue management, you might want to, let me explain what that is. You might want to analyze people in retail and find out how long they are waiting in line before they get to the cashier. Or maybe you want to make a product for construction site safety. You want to make sure that people are wearing their safety equipment. You might want to do something in factories or restaurants, or make sure that people aren't smoking. So the number of use cases for video analytics is almost infinite, and we're sure that people out there who are bright and have better ideas than us will want to make great products in the video analytics space, but they might not have the expertise to deploy these things. So what they have to do is they'll just make capsules in the open vision capsule format. So for example, here I've put a capsule for vehicle detection, a capsule for person detection, a capsule for recognizing the make and model of cars. So the idea is you find your problem, you pick your capsules, and then you configure your BrainFrame. But what we want is to have almost no programming. We want it to be so easy for people who want to solve a problem to just click and drag everything they need and then deploy. So let's get a little bit technical. How does our system work? Well, you can connect smart cameras, IP cameras, video files, or webcams, and they enter into the BrainFrame server. BrainFrame handles the video processing. Your chosen capsules run the algorithms. This is where the machine learning, the AI, the deep learning happens. And then BrainFrame will save all of that analytics to a database. It'll host a dashboard for the user on their browser so that they can see graphs and real-time analytics of what's going on. And on the user side, they can also view a client. So they can see the video, they can see the people detections, they can see what's going on, and then they can tweak different parameters until they're getting the exact information that they want. And again, this is supposed to be as usable as possible, very easy to use, and let more people enter the video analytics space with less expertise. So let's do a demo. Let me show you what I'm talking about. So let me explain what you're looking at. Right here, this is the BrainFrame client. So this is what a user might run on their computer if they want to add videos to BrainFrame, they want to analyze different things. Here on the right, these are the algorithms that I've loaded into BrainFrame. So far, I just have a people detector algorithm. So let me go ahead and let's add a video. So I'm going to start by adding a roadside camera here. And so with BrainFrame, you can select IP cameras, webcams, or video files. So I'm selecting an IP camera. This is being hosted at my office. Okay. And so then once you add the camera, it's going to take a little bit of time to load the stream, but then we should be able to see live video. So let me go ahead and click that. Okay, perfect. So what you're seeing here is this capsule, this open vision capsule, is detecting people. And you can see all the person detections as they walk down the street. And it's doing this live, right? So BrainFrame is doing processing, it's sending it to the client. We're getting information about where all the people are in the video stream. So then the user might say, well, I want to do something different. I want to track these people. So you might notice that, that right now we're detecting these people, but we actually don't know where they've been in the last frame to the next. So we want to know, for example, where they're walking, the exact trajectory as they walk through the screen. So what you can do is you go to our downloads page and you scroll down and you download different capsules. So I'm going to download a person tracker and a person encoder. So now I've got these downloaded. Now watch this. It's so easy to add new capsules to BrainFrame. You just click and drag them in. So now that I've done that, you'll notice that the people have lines behind them. I hope this is showing up on the video. This may not be showing up very well, but the idea here is now I've added new capsules. BrainFrame loaded them, put them onto the hardware accelerated platform, and is now showing the results live. So now that we're tracking people and detecting people, you might want to know the traffic, the amount of people that are walking by the screen. So to do that, BrainFrame has a feature called lines and zones. And so all you have to do is create a line. So I'm going to create a line here for the sidewalk 1. And you just click and drag. And I'm going to make one for the road. So the idea here is if you want to count the amount of traffic of people walking by different parts of the screen. So in a retail scenario, this is helpful to know the amount of traffic of people walking around different areas of the store so that you can best optimize the store layout. In construction site safety, you might want to make a zone that keeps track of the dangerous areas of the construction site and warn other people when someone enters that dangerous area. Right now, I'm just counting people. So in the time I've been talking, 11 people, 13 people have crossed in this direction and 4 people have crossed in the other direction. So that's simple enough, but can we use it for other things? So we can also use it for traffic. So I'm going to add another video here. This is a traffic example. And so just like last time, I need to add another capsule for tracking cars. So I'm just adding that in there. And let's wait for the video to load. Perfect. So that person detector also tracks cars. And BrainFrame is fully featured. At any point, you can click here and find out what kind of algorithms you have loaded. So if you are an algorithm developer, you can very easily give your users a good experience by tweaking different algorithm parameters. So with this traffic example, in a smart city scenario, it's very important to track the different kinds of vehicles that are traveling through a road. So I'm going to use that line feature that I used last time. In this case, I'm going to track vehicles going through the bus lane because I want to make sure that only buses are going through the bus lane and not cars. And then I'm going to make one for the slow lanes. So these are these 3 lanes here. These cars should move slower than the rest. And then I'll make one for the fast lane. And so in this scenario, I'm showing how I can count the number of different vehicles, not just cars and buses, but I can count that 12 cars cross through this line, and that 1 bus cross through here, and 2 cars cross through here, right? Oh, the stream appears to be frozen on the Zoom. Let me see here. Try to add that. Oh, I'm going to move on to the next scenario here. So let's move on to a more realistic use case. So here is a cash register shopping scenario. So in this use case, smart retail is becoming a bigger thing every day, and we think that people are going to have big, bright ideas for what to do in smart retail. And so I wanted to show off an example of something that you could do in a smart retail scenario. So I'm just waiting for the video to load. So one of the common problems in smart retail is being able to track how long customers are waiting in line. So that's very important because you want to know if the customers are having a good experience, right? If on average customers wait longer than 2 minutes, they might be dissatisfied with their service. So they're going to want to, the store might want to hire more cashiers during those times of day. So to gather those analytics, you use something called a region. So here I'm going to call a customer line number 1. And to create a region, you just click and drag until you've filled out the exact area that you want to track. And then I'm going to create one for the second customer line. Okay, perfect. Great. And once you've created your regions, you can now keep track of how many people are inside of every region. And not just that, but how long they've been standing there, because we are also tracking those people. And so now what I'm going to do is I'm also going to track where the cash registers are, cashier number 1. Because what if there's someone waiting in line and then the cashier leaves? It would be probably important to automatically get another cashier into that area. So let's go ahead and add a cash register there. And so now you can see I'm tracking every part of the scene, and I'm keeping track of which people are where. So now I'm going to show off a feature called alarms. So in BrainFrame, you can create rules to keep track of different scenarios. So you can create an alarm, for example, called no cashier. And this alarm will trigger whenever there is equal to 0 people in cash register 1, right? And so the idea here is you can trigger different alarms when different situations happen. So if this cashier leaves this register, then the alarm will go off and we'll immediately be alerted that the cashier left. So the idea here is that users who make things with BrainFrame can load their capsules up, create different custom rules depending on exactly what it is that they're trying to extract from the video, and then deploy it through our client and integrate it into existing systems. So in this case, they might integrate this into the comm system for the store to automatically say, you know, more cashiers needed in cash register number 1. So now let's go in and let me connect a live video here so you can see me in my room or my mobile office here. Perfect. And I'm going to show off a couple other algorithms. So, hello, there we go. You can see a very custom camera here set up. So now this is going to be a little bit more free show. You can see here as I move around that I'm being tracked. Unfortunately, the camera is very low to the ceiling, so if I stand up, you'll lose track of me. I'm too tall. So I'm going to show off a little bit of other features. So you can see right now that the faces are not being detected. So I'm going to add a face detection algorithm to BrainFrame. And so just by clicking and dragging, I was able to add that face detection. Now you can see my face and exactly where it is on screen. But BrainFrame doesn't just offer face detection. The OpenVision Capsules format allows you to build algorithms on top of other algorithms. So let's say you want to find out more information about my face. So you can go to the download section of the website, look for things that require face as input. For example, if you want to know if a person is wearing a hat, or if they're a boy or a girl, or if they're wearing sunglasses, or what kind of behavior they're doing. All you have to do is download that capsule and plug and play. So right now I'm going to load a capsule that tells me what kind of glasses I'm wearing. So I've just dragged that in there, and we're going to give it a moment to load. So every time you drag something in, BrainFrame loads it onto the GPU. And I don't know if it's visible right now, but right now it says no glasses, right? So it's correctly identifying, it's getting the face input from one of the algorithms and then running classification, which is a type of algorithm to find out what kind of glasses I'm wearing. So now if I look at the camera and I put on my cool sunglasses, you'll notice that it turns to detecting that I'm in fact wearing sunglasses. Now, BrainFrame also supports something called encoding. So all of these state-of-the-art face recognition algorithms are able to describe the appearance of a person's face. So if I drag in a face recognition algorithm here, nothing happens yet. BrainFrame still needs to know what my specific face looks like. So I've dragged in a face, and then for all the face recognition things, you can very easily add new faces. So I'm going to go ahead and upload a picture of my face, and then BrainFrame will be able to recognize it. And so in here, there's just 2 pictures of my face. And you can upload multiple different faces. So let me try that again. Okay, perfect. And so now if I look at the camera, it should say Alex Peel under my face. Right. And so the idea of this is it should be very easy for people to do employee recognition in a smart store scenario, or if they want to track when a bad actor, someone who is a known shoplifter enters the area, or if they want to do identity verification, all they have to do is drag in the correct capsule and use the existing framework to do this. And furthermore, if a company already has AI expertise and they already have very good algorithms for face recognition, then all they have to do is wrap it inside of an Open Vision Capsules format and deploy it through BrainFrame. BrainFrame handles all of the rest of the deployment aspects. And not only does BrainFrame have this client, but it also has a dashboard. So you can go into BrainFrame and see different graphs. So I think right now we have a graph here for the streams that have been up. And you can also create new queries. You can write SQL queries down here. I'm not going to get too into this, but it's very easy to extract real live data from BrainFrame out of the box without being a programmer. So now I'm going to switch back to the presentation, and I'd like to find out what kind of questions you guys have as to, and in any specific use cases you might have questions about. So let's move on to that portion, and please visit us at our forum. We love developers, and try out BrainFrame. It's available for free right now.